Hi guys, in this video we're going to be talking about glycogenolysis. Glycogenolysis is the process of breaking down glycogen to yield individual glucose molecules. You might find this process hard if you haven't understood it yet, but I want to assure you that it's not that hard, and I'll try to explain this process in as simple terms as possible. There are 3 or 4 major enzymes that take place in glycogen metabolism or glycogenolysis, and I'm going to be talking about all 4 enzymes in this video. Now first, let's start with the structure of glycogen. So here I drew a glycogen. Now this is just an enzyme that I drew over it, and ignore this line and this big circle. And glucose molecules are attached in glycogen by alpha 1,4 linkage like this one, this one, this one, this one, or by alpha 1,6 linkage like this one. This is still alpha 1,4. Now let me remind you what reducing and non-reducing sugar is real quick. So let's talk about this last glucose molecule in this glycogen. So in this one, the oxygen in the anomeric carbon is free. So if the oxygen in the anomeric carbon is free, it's called reducing sugar. But you can think that in all these glucose molecules in between, this oxygen would bind to another glucose molecule, so this would not be free. So all these glucose in the middle or at the end are non-reducing glucoses. Now let's start to talk about glycogen phosphorylase. Now here I kind of drew a structure of glycogen phosphorylase. Glycogen phosphorylase cleaves individual glucose molecules from glycogen, and after cleaving it changes them into glucose 1-phosphate. And I talked about reducing and non-reducing sugar because glycogen phosphorylase, it starts from the non-reducing end of the glycogen. So glycogen phosphorylase starts from here. It doesn't start from here and go up. It starts from here and comes down, or it starts from here and comes this way. Now it takes some glucose molecules in and cleaves one at a time, but once it reaches last 4 or 5 glucose, it cannot cleave any more glucose. So let's say once the glycogen phosphorylase cleaves this one and this one, it won't be able to cleave any more glucose because there are only 4 left. And these 4 glucose left, they are called limit branch. Now here you can read what are the allosteric activators and allosteric inhibitors of glycogen phosphorylase. Let's go to glycogen debranching enzyme now. So once there's last 4 glucose left, this glycogen debranching enzyme takes 3. It only takes 3, it doesn't take 4. It takes the 3 glucose from this end and attaches it to another branch. So let's say it takes these 3 glucose and attaches it right here. And for this last glucose, it hydrolyzes it and makes a glucose. You can see one difference. Glycogen phosphorylase makes glucose 1-phosphate by cleaving the bond, but glycogen debranching enzyme, it makes glucose by cleaving alpha 1,6 bond. And glycogen debranching enzyme can also be called glucosyl transferase. Glucosyl just means 1 glucose unit, and you can see how it transferred these 3 glucosyl units. Or it can also be called alpha 1,4 transglycosylase enzyme because it makes alpha 1,4 bond right there. And our third and fourth enzymes are pretty simple. The third enzyme, phosphoglucomutase, it converts glucose 1-phosphate made by glycogen phosphorylase enzyme into glucose 6-phosphate. That's what it does. And the last enzyme is glucose 6-phosphatase. And glucose 6-phosphate cannot exit cell by itself, so glucose 6-phosphatase converts glucose 6-phosphate into glucose. At the top I said that this process includes 3 or 4 enzymes. If someone says that it includes 3 enzymes, they're talking about enzyme 1, 2 and 3. But if someone says it includes 4 enzymes, they're talking about all 4 enzymes. And muscle and other tissues other than liver lack glucose 6-phosphatase, so they can't convert glucose 6-phosphate to glucose, so they have to retain their glucose 6-phosphate. This concludes my description of glycogenolysis. Thank you for watching my videos. If you guys have any question, please post below. Bye.